Welcome Algebra 1 students to our video on relations and functions. This is a vocabulary heavy video with just a few skills that we're learning as well. So let's get started. Okay, starting with some vocabulary. A relation is a set of ordered pairs. So x's and y's ordered pairs is a relation. It's just any set of ordered pairs. It may or may not have a rule that goes with it, but that's the only definition of a relation. The domain of a relation is the set of all its x values. So the domain is the set of all the x values. The domain is the set of all the values of the inputs for that relation, the input or the independent variable in that relation. So the domain is the x values. The range, well, that's the y values. So range, y values. It's the output. You put in the x and out comes the y. It's the dependent variable. The range is the set of all the numbers in the dependent variable. A function is a relation where each output has exactly, where each input has exactly one output. That means that no x values have more than one y value. So in other words, you can't duplicate the x values if you want it to be a function. So in a function, the x values are not duplicated. How do we display a relation? Well, you have the first way you display a relation, actually is the third one on the list, is this graph right here with x and y axes and points on the coordinate plane. But I can also make a table for my graph, and I would have x and y values on the table, -1, 3, let's see, 0, 0, 1, -1, 2, 0, and finally 3, 3. So there's a table for my relation. A mapping is a very specific thing. I do want you to know the rules of making a mapping. It starts with two ovals, big enough to fit your x values in numerical order and your y values in numerical order. So since I already made the table, it does make it a little easier to list my x values, but notice my y values are not in numerical order, so we're going to list those least to greatest, -1, 0, and then 3. And to finish a mapping, with a mapping you go through and you draw little arrows from the number in the x that goes with a number in the y oval. So -1, 3 is a point, 0, 0 is a point, 1, -1, 2, 0, and 3, 3. So you can see what ordered pairs are there while still having the x and the y values in numerical order. A mapping does have some benefits, but we'll talk about that in a minute when we get to looking at whether or not something is a relation is a function. Okay, we already looked at the graph right there. And then you could have an equation that's in function notation for a set of ordered pairs for a relation. And in this case, most of those would then also be a function, because it is called function notation. This particular set of ordered pairs does have a related function. We'll do more with that later, but I'll just tell you it's x squared plus 2x. And that will actually give you, if you put in your input value, you will get out that output value. So if you put in an x to this function right here, it's okay if you're not familiar with this. You should be a little bit, but if you're not, that's okay. You put the x in, and out comes the y. And so this is the function rule for all of these ordered pairs. But we'll do more with that later. Now, how do you tell if a relation is a function? Well, you're going to examine the domain. You're going to use that vertical line test. We'll explain that in just a minute. So let's start by looking at this particular line. Now, in this case, this line goes forever to the right, forever to the left. Every x value is used only once because this isn't going to suddenly turn around or bend back or go the other direction or anything like that. It's a straight line forever. Otherwise, those arrows wouldn't be there. So this most definitely is a function. Okay, so remember, in order to not be a function, we have to have duplicate x values. Now, here's an example of one where we're definitely going to have something that's not a function. So, in this particular problem, if you look, it's a circle. That means that I can already tell that, for example, here at x equals 1, there are two different y values that have the same, two different y values that have the same x. And I could, in fact, draw myself a little vertical line for that particular there we go. So I can have this vertical line right there. It's touching it 2 times. In fact, there's lots of places where it's touching it 2 times. So this is not a function. This next one, well, again, I could take my vertical line and sweep it across, or I can just look at the shape of the graph and understand that this is curving outward. Whoop, did not mean to move that, sorry. This is curving outward, and it's continuing to curve outward. It is not going to become a vertical line. So I can see that every x in this case would also have one and only one y. So this one is a function. If you have a graph, you're going to have to use your understanding of the information as well as the definition of what a function is to figure out if each one is a function. Each relation is a function. And that vertical line test is a good help for that. But keep in mind, if you have a list of ordered pairs or a mapping, you're going to want to look at that a different way, and we'll practice with some of those in class. The other thing I want to talk about today in this video is function rules. A function rule is an equation where the input is represented by x and the output is represented by f of x. F of x is read f of x, duh, because that's what I just said when I read this. F of x is read f of x, which stands for function of x. So please don't say fx, that's a TV network. It's f of x. You can think of your function machine as exactly what we were talking about. Put in something, get out something else. So you put in your independent variable, and what comes out depends on what you put in. You'll see other letters used for functions as well. So you can have f of x, but you can also have g of x and h of x. I think g and h were used merely because they come after f in the alphabet. Let's look at how we might be expected to use a function rule. Well, to use a function rule, what you're going to do is you're going to find the value. You're going to evaluate that function rule. So if I start off, for example, with this first one, which says f of 3. Well, I have the rule that f of x is 2 times x. So f of 3 means replace the x with a 3, do the math, and f of x is equal to 6. Or excuse me, f of 3 is equal to 6. Do the same thing for the next one, except this uses a different function rule. It uses g of x, which is x squared plus 1. So I'm going to plug in x squared plus 1. Negative 2 squared is positive 4, plus 1 is 5. So g of negative 2, that's equal to 5. For the next one, I have f of 2/3. So that means I want to multiply 2 times 2/3. Well, I've learned that whole number times fraction is whole number times numerator. Don't make it harder than it is. So 4/3 or 1 1/3 are the correct answer here. I do not want to see 1.3. Repeating bar notation would be at a minimum what you need to have in order to write that as a decimal. And then the last one here today is g of negative 1/2. So I'm going to take this and plug in negative 1/2 for x squared plus 1. Well, remember, when you square a negative, you get a positive. And when you square a fraction, you square the top and square the bottom. So this is 1 1/4 or 5/4. So that's if you are asked to just evaluate a function for a single value, but sometimes you are asked to take the function rule and find the range if you're given a domain. So if they give me a domain, they're telling me here are some x values. In this case, we have 1, 2, 3, 4, 5 x values. And what we're going to do is we're going to evaluate each function for those 5 x values. So that means for the first one that I'm actually going to find f of negative 3, f of negative 1, f of 0, f of 2, and f of 3. So f of negative 3, f of negative 1, f of 0, f of 2, and f of 3. And you're plugging each one in to the function rule that you're provided, which is 3x minus 4. So 3 times negative 3 minus 4 is negative 9 minus 4. That one comes out to negative 13. 3 times negative 1 minus 4 is negative 3 minus 4, comes out to negative 7. So far we have negative 13, negative 7. F of 0 is 3 times 0 plus 4, which is 4. And f of 2 is 3 times 2 plus 4, which is 10. 6 plus 4, or 10. Finally, f of 3. 3 times 3 minus 4 is 9 minus 4 is 5. So that means that the range that came out, the output that came out here, is the set of numbers negative 13, negative 7, 4, 10. Oh, nope, it's not 10. Hello. That was close. It's minus 4. This should have been a 2. It's minus 4. This should have been a negative 4. I caught myself. I know some of you are probably getting excited and starting to write me an email already about how I made a mistake. Haha, joke's on you. So I found my mistake. All right. And so those are the answers for that first set. Now I'm going to do the same thing for the other 3, but I'm going to pause it so that we're not sitting here half the day. And I would like you to also pause it and try them yourself. So here come your answers for 2, 3, and 4. Phew, that was a lot of writing. Okay. Hopefully you took the time to do this out as well. If you didn't write them out, then that's fine. Just keep an eye on whether or not you're making a ton of mistakes, guys. Remember, it's not that you're not good enough not to write it out. It's just that you need to be able to have that visual. Okay, so you'll see in each case a range. Now I want you to notice a couple things. First of all, in the first one, it's in the same order in which we actually got the answers, but in the other ones, it wasn't. I put it in order from, well, in 3 it was. I put it in order from least to greatest, because that's how we should display the range. So when you plug in the x's, out come the y's, and put it in numerical order. So double check your math. Notice that there's only 4 values in the fourth one, because one of them came out twice, and that's okay. It's okay to duplicate y values. It's just not okay to duplicate x values. Okay, so that's how we deal with a function rule. One last example. Okay, how about working backwards? Say that they give us f of x equals 6x minus 4, and they say the f of x for some value of x is 26. Find x. Well, we can do that really easily. All we're going to do is take that f of x equals 26, and we're going to plug that in and make an equation. If I now solve my equation by adding 4 and then dividing by 6, I have found the mystery x value. That x value that they had plugged in, it was 5. So we can work backwards to find that missing x value. So make sure you know the definitions and the uses of domain and range, and how we'll be operating, using the different operations with the function rules with f of x. And I'll see you guys in class.